Hello. Okay, so we are live again and welcome to the stream. Okay, so we are live again and welcome to the stream. So today we'll be solving this problem. Where is this? Where is that? Digit sum is done. Okay, so grouping. We'll be solving grouping. Okay. We will be solving grouping, so let me add a boundary. Okay, so I hope I'm okay. Seems good. Okay, so let's go over the problem statement. It says that there are n rabbits numbered 1 to n, and for each ij, the compatibility of rabbit I and j is described by an integer aij, and self compatibility is 0, and also it is symmetric, that is aij is equal to ajia. So aji, so Taro is dividing n rabbits into some number of groups, and each rabbit must belong to exactly one group. Okay, and so after grouping, uh, Taro earns aij if ith and jth rabbit are in the same group. So we have to find the maximum possible score. Okay, constraints, you can see n from 1 to 16, aij 10 to the power 9, aij 0, aij is equal to jj. So n is still 16. Okay, so what comes to mind when it is like under 20 or 16? Bit masking. Okay, I'm not a pro in this bit masking also. I can see that there will be a bit masking, a solution of this, but I cannot form that solution. Okay, so let's see. Suppose this is the matrix of let's say this is a matrix of compatibility. So ij means first rabbit and second rabbit have compatibility of 10. Okay, so if we take all the n rabbits in a mask, let's say so all the rabbits are in a mask like this. Where some of the bits are some of the bits are 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here n is equal to 12 right now. So we have 12 rabbits and we want to make groups is that the score is maximum. Okay, and we now have, okay, so what does 1 represent here? 1 will tell you that rabbit not in any group, and 0 will tell you that already grouped. Okay, so if we have a mask like this, what is my next move? My next move will be to combine all the remaining rabbits so that I can get a maximum score. Okay, so we want to combine these rabbits in a way that we have a maximum score. Okay, So how do we do that? Basically, we need to iterate through all the submasks for the grouping, right? We need all the submasks for the grouping, and when we have divided it into the groups, we will add the score corresponding to that mask, and that way we will get the maximum answer. So the transition, or let's uh, so let's say what will our state look like? Our state will be dp mask will be the maximum score uh, given the initial mask. Maybe it just means that whatever mask that we have, what will be the maximum score for that group, for that those rabbits. Okay, so okay, what will be the base case? Suppose we don't have any rabbits, or all the rabbits are occupied, or all the rabbits are already grouped. Then in that case it will be 0, right? We can no lo- we cannot we cannot group any more rabbits, so there will not be any compatibility score for them, so it will be 0. Third is, what will be the transition then? Okay, so like I told you that dp mask will be nothing but maximum of the mask score, maximum of a submask score. So basically we'll iterate through all the submask of the current mask, okay, such that we have the mask score of the submask. We will add that and then recursively get the value for the remaining mask. So basically submask and like XOR with the current mask. Okay, so what this will do is that if we have chosen this mask to be my group, then it will be removed from this mask because of this XOR rate. So we will calculate for the other rabbits then, the remaining rabbits. We will calculate for the remaining rabbits then. Okay, and out of all the possible submasks, we will choose the maximum and set it to dp. Alright, and the answer will be what? dp of 1 n minus 1, all the bits set to 1, that is all the rabbits are available. Hmm. Okay, so for this we also need to calculate this, right? Mask score. how how will we calculate it? So it is simple actually. We will run all the mask. We will iterate through all the mask score. Basically, iterate through all the mask from one to this, and add aij if both ith and jth rabbit are available in the mask. So basically it will be a loop. Okay, so we will go from 1 to n, then we'll go from what 0 to n, will go from 0 to n, we will add if condition met, and this will be okay mask. This will be how our mask score will be calculated. So time complexity will for this will be n square into 2 to the power n. Okay. Time complexity will be this. And now for the DP part. For the DP part, we have n bits. So for all the mask, we'll need to iterate through all the mask. Okay, 1 to this, and then we will be iterating through all the submask. And the thing is that if there is a bit set in the mask, then let's say if there are 2 bit set, if there are k bit set, okay, if there are k bit set, then it will be like we have 2 to the power k options of making a mask, right? Say we have this 0 1 1 1 0 0, so we can have different submasks, right? Like for example this or this, and there will be like 8 different options. Okay, so the time complexity, if we go via like simple brute force technique, it will be 2 to the power n and 2 to the power n, which is 2 to the power 4 to the power n, and this is not feasible for n is equal to 16. So instead of that, what we'll do, there is a very cool blog on CP algorithms for submask enumeration. Okay, so here we'll be using this. Okay, this. So it is 3 to the power n for enumerating the complexity for this is 3 to the power n for enumerating all the submasks. So we'll be using this. Okay. So let we will use CP algorithm submask enumeration. Time complexity is 3 to the power n. Okay. How it is 3 to the power n? It is a mathematical proof, not like very complex one. It is already given here. This is a binary binomial, theorem, like 11th or 12th standard. I think 11th standard. Yeah, 11th standard problem. So yeah, this thing is, they are basically adding all the combinations of submasks, and that actually leads to expansion of a standard binomial expression. So basically they are doing like this. So we have 1 plus x to the power n leading to this 2n and nck. We have x to the power n k. Okay, from 1. So something like this. Oh, they're going from 0. So if you add 2 here, so it will be 1 plus 2 to the power n is equal to k is equal to 0 n c k 2 to the power k, which is nothing but the possible positions of our k bits and the number of submasks possible, and the multiplication of this and then adding it is basically all the enumeration of the submasks, right? So that is equal to nothing but 3 to the power n. So at most we will have 3 to the power n time complexity. So how they are doing it, this is the formula that they are using, s minus 1 ampersand m. So we'll be using that also, that only. Okay, so let's implement this and see if we can do it in first try. Based on the record, we will not be able to. I think we have never been able to solve a complex problem in single try. Okay, don't need u. We don't need u. Okay. Input is n. Input is n. We have a matrix n cross n. So should I? Okay. Let's name it A only. Size is n. And then we have simple things like input. Okay, input is done. After that we will have a mask. Okay, So we will have a mask. Mask is basically mask score basically. So 1n, so 16. Okay, so we won't be needing uh, a long or maybe, because the size is manageable, right? Anyway, the mask will still be this only, plus 1 0, and we also have a dp similar to the last one. This I will set to minus, no, not minus. Okay, so it can be minus. The compatibility can be negative, so as you can see in the inputs, compatibility is negative. So we will have to use negative 1e8 maybe. And since we are adding na, so I think we'll need VLL. We will need VLL, or for this also. A can be 10 to the power 9, right? So 16 10 to the power 10, most probably this. Okay, 10 to the power, but it will take longer. Okay, so we have everything now, and now what we'll do, we'll calculate the mask score. So we'll have a mask going from 0 to this. Okay, we'll go from 0 to this, and here we will go from we will iterate all the combinations. Okay, and check if like this is happen, the ith bit is set in mask, and if the jth bit is set in mask. If it is, then we'll do is we'll add the I'll add this. So we got our mask score. Okay, after this we'll for dp, before that we'll set dp 0 as 0. Okay, answer will be are we modding anything? No. So answer is this. Okay, and here we will go again from mask, going from what, we'll take from 0 only all the way here, and inside you'll have a custom follow where the submask, okay, submask will initially be mask only, and we will go till submask is not 0, and submask will become what, submask minus 1, and with mask. So this is the enumeration, and then we'll do mask is equal to maximum of dp mask and the mask score of the submask plus dp mask XOR submask. Okay, so think this is it. Okay, segmentation filter. Why have you used capital N? 40, is it the correct answer? 20 is the correct answer. Okay, okay, so I get what is happening. I'm actually calculating the mask score for all the, so basically what is happening is I'm calculating ij also and ji also, so I need to fix the position. Yep. Okay, oh my god, 132. It is so complex, but see how easy it can be solved. The problem, if you try to tackle it using by hand, it is very complex. Wrong answer, TLE, MLE, anything. Damn. Okay, grouping is done. Permutation, I have no idea how to do, so I will not be going into this. Subtree. Subtree. Number of ways in which this can be painted black. All the possible permutations, and then we can, but n can go 10 to the power 5, right? So it will not be easy to do, and it is also a tree. Okay, so how many ways are there to paint a vertex black? Basically, if we, instead of solving that problem, if we have if we pre-solve the problem, okay, if we pre-solve the problem and then answer the query, what I'm thinking is, if we solve the problem that how can we paint a tree given that how can we paint the tree in black or white given that to paint black we can only move from black. Okay, so basically we need to make a black connected black nodes. So how many ways are there total? It can be disjoint black nodes as well, but no, any black vertex na, so it cannot be disjoint. Black vertex has to be a connected component. Okay, so that component size can be changed, plus we can have a white tree as well. So V sub tree. Okay, so we can have a tree like this. Let's say we have a tree like this. So to paint it black, we have options, right? We can paint this one black, leaving others as white. Or we can plan to expand on this black part and include this here. Okay, black part should always be connected. Or we can also expand on this, so it will be like this. So there are different ways, right? So for in each way, so we can see that this node is included in all of these ways. So at least to paint this node black we have at least 3 ways, but I can see that there will be many more because the lower level nodes have not been painted yet. So I think if we can calculate the total number of trees, or no, basically if we can simulate the painting of trees in a way, in this way, we may be able to store the count of how many times the node has been painted black, and that will be our answer, I think. But that simulation of painting will not be easy. And anyway, if it is like in incrementing the value of the node, no, if the node has already been painted and we choose another one, okay, then we should include that node again, right? But then this will be How will we then calculate it? Hmm. Yeah, I'm feeling very sleepy. I don't think I can solve this today. And as a matter of fact, I don't think I can solve any problem today anymore. But the only idea that I have is that black color is a connected component in this graph. But that doesn't make any sense actually. We can have different sized numeratic that will take a lot of time actually. Yeah, it will take a lot of time. It's not an optimal way of thinking, I think. No, it's not an optimal solution path. The component part is, I don't think it is optimal. Something else. So, if I had only 3 nodes, okay, so the number of ways uh, this node can be colored black is so let's say if I have this, okay, simple. So if we take it as TPU as number of ways vertex U can be colored black, then the transition, okay, so the transition should be, or what I think it is, I can have a combination of them. Either this or this, or maybe all this. Yeah, I'm not sure. Think that's it for today. I'm actually very tired from all the work. Oh yeah, this was a very short stream. I think like only 45 minutes. But yeah, we were able to solve one question, and the second one I don't think I can right now. My camera is very bad, but I don't think you can see my eyes actually. Yeah, I'm very sleepy. But I will not sleep. I'm going to play some games, I think. To like wake, or maybe we'll have a stream tomorrow, morning or afternoon, maybe, to cover up some of the things and solve some more problems. And I think maybe we should start graph as well, Because DP problems are now okay. Yeah, we will be switching to lead code also. Yep. But I think in lead code we should do should do lead code in a month actually, maybe. Because we I want to like have the foundation of all the concepts first. Like I want to revise all these things first. So yeah, maybe we'll have to, but also there is a contest tomorrow, na, atcoder contest. So if I give that for 2 hours, if I have a stream before that for 2 hours or maybe 1 hour, and after that I play on games again, and in the morning I will be uh, using laptop anyway because it's my habit. What I say, I cannot live without my laptop actually. So I don't think I will be able to, or maybe I will. Let's see. Yeah. But yeah, that was it from my side today, and I hope you have a good night, very good night. I hope you play games over this weekend. I hope you meet your family, enjoy some time with them, and have fun. So, peace out.